right, so another possibility that when we come across a counting problem that we might encounter are combinations. They're like permutations, but different. Okay. The notation for them looks quite similar. Of course, it's a combination, so of course it's a C or NCR. So if you've got your calculator, you might see that button pretty close to the NPR button. All right. Now, let's just get a combination, calculate a combination here. Combination of 20, choose 6. $38,760. Now, just for comparison's sake, let's do permutation 20, choose 6. Permutation 20, choose 6. What do you get there?
2016.
27, 907, 200 is what I get. Comparatively, what do you see? Way less, way less. So yeah, here's the reason that is. The number of combinations is always a lot smaller than the number of permutations. Here's why. On permutations, those are like when first, second, and third place occurs. So you got A, B, C, for example, if I'm doing the places. All right, so permutations counts then A, C, B. That's a different one because that would be first is A, second is C, third is B, with me? And then I could also do B, A, C, and B, C, A. So you see there's a lot of different permutations of that. Combinations, the order doesn't matter. So that's important. On combinations, the order doesn't matter. In other words, A, B, C, if you try to rearrange those, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. Those are all the same as A, B, C. The order doesn't matter on combinations. Order doesn't matter. So if you got A, B, C, none of those other ones count. You with me? They're not like permutations where rearranging them matters. Combinations, the order doesn't matter. So that's why you have so many, because on the permutations, these all counted. On combinations, they won't. All right? So you're going to just have one out of all these possibilities, you see? So instead of 1, 2, 3, 4, 5, 6, all those counting, just one of them counts. With me? Order doesn't matter. So that's very significant. Because here's the thing, you got to recognize when to use a combination, because basically you have to use the combination button. The permutation button, you don't have to use it. You can just write out the numbers, 20, whatever. Combinations, you basically have to use the combinations. All right. So if you have n things taken r at a time, so it's basically the same as permutations, and the order doesn't matter. Underline that. then use NCR or CNR. So if you've got in things, you're going to do R of them at a time, use NCR or CNR. Combination. It's a combination, okay? Okay. All right, so here you go. So let's say we got club in. And it's Andy, Bill, Kathy, David, and Evelyn. How many committees of 3 could they form? How many committees of 3 could they form? Well, remember back when we talked about last time listing out committees? All right, so we got A, B, C, but when we go to list out all the committees, I could go A, B, D, A, B, E. All right. Then I could go A with C, but could I do ACB there? Why not? ACB is the same committee as ABC, right? So it's not ACB next, it would be ACD. The order here doesn't matter. In other words, on committees. I didn't finish the list, but I'm just sorry, we may finish it here in a second. Are you with me there? Order doesn't matter on committees. So guess what they are? They're combinations. So this is a combination. Committees are always combinations. So what's the significance of that? Well, all right, so unless I want to list them out, I'm going to have to use this CNR business. Okay? Now, what's the N and the R here? N is the number of total things there are. 5 people, right? R is the number of them I want at a time. How many do I want at a time? I want committees of 3, right? So I need to do combination 5, 3. What do you get there? 5 NCR 3. That's 10. There's only 10. So if I was going to list these all, let's go ahead and list them all out. All right, let's finish our list. So I did ABC, ABD, ABE, ACD. Then I could do ACE, right? Then I could do ADE. That would be, because I had to have at least one of those different, a different member, different person, to be a different committee. All right? Then I've got, what else? Then I think I'd have to go to the B's then next, wouldn't I? B, C, D, B, C, E. Then I could do B, D, E. Again, you have to have at least one of them different. So I couldn't do BDC because I already got BCD, see? What else? C with D and E. I believe that's it. 1, 2, 3, 4, 5, 6, 7, 8. Ta-da. Okay. So instead of having to list these all out, we can figure this out with a combination. Okay? All right, so let's make a little different problem here. We'll talk about committees again. something else. In a club with 13 men and 17 women. Find the following. Number one, how many committees of 6 can they form? All right. So yeah, on the ones we did with listing, we did small numbers of committees. When we get bigger sized committees and numbers of people, it doesn't make sense to list all the committees out. We just want to know how many total there are. So how many committees of 6 here can they form? Well, again, now that we know about these combinations, we have to ask ourselves, does the order matter? And if the answer is no, the order doesn't matter, then it's a combination. If the answer is yes, then use blanks. Basically, that's what it is. If the order doesn't matter, you use a combination. If order does matter, you use blanks. Okay. That's fun we got this one. Well, we already said committees, the order doesn't matter. So does order matter? No. So it's a combination. Now, in a combination NR, what is the N again? The total number there are to choose from. What's in here? How many do I have to choose from? How many people do I have to choose from? Well, I got 13 men and 17 women. I got 30 people, don't I? I want a committee of 6. So I want R6, right? So combination 30, 6, 30,6. What does that give you? 30 NCR 6. I get it. 593,775. Anybody believe that? Okay? All right, number 2 here. How many committees of 5 with 3 men and 2 women? We got 5. How many committees of 5 with 3 men and 2 women? Well, we've already established committees, that's a combination. Order doesn't matter, so it's a combination. It's a combination. All right. Now, the question here is, so I want to split this up. I want to divide the men from the women. How am I going to do that? Well, the answer is I do a combination for each. So I'm going to do a combination for the men and then a combination for the women. Okay? So that'll separate it out. Divide it out. Because here, 32, I don't know what, I mean, it may be 5 men and 1 woman. It may be 3 men and 3 women, right, with me? So if I want to separate them, if I want to know it's 3 men and 2 women, that's what I've got to do. All right. So the 3 men. Let's talk about the combination for it. So the N is how many possibilities there are. I'm only talking about men. How many possible are there?
3.
Nope.
5.
Nope.
3.
There's 13 men possible, right? I can choose any of those 13 men. I want 3 of them. So it's 13 comma 3. Yes? Make sense? There's 13 men I can choose from, and I want 3 at a time. What about the women?
17,
I've got 17 to choose from,
2,
and I want 2 of them. Now, the first thing we might note here is it's committee of 5, but when I put in the numbers, the 5 is not used, right? Because I split it up into 3 men and 2 women. That's the 5. 3 plus 2 is 5. That's where you get the 5. Okay? So don't let that not using the 5. So 3 men, 2 women. So it's 13, 3, 17, 2. Everybody see where we get that? All right, so let's put those in. 13, 3 is 13 combo 3. That's 286. 17 combo 2. 136. Now, 2 numbers. We can combine 2 numbers a lot of ways. We can add them, we can subtract them, multiply them, we can divide them. Here's a little hint for you. All right, so 3 men and, where is and there? In mathematics, and this will come up a couple of times, I think as we go along through our course here, that word and in mathematics typically means multiply. And means multiply. Or, if you see the word or, that typically means add. There's little catches, but and means multiply. So multiply, multiply. Yeah, I'm going to multiply those 2 together. 286 times 136. Not add, multiply. 38,896. Okay. All right. So order doesn't matter. You use combinations, and you just want to write it down. You got a committee. That's going to be a combination. You're going to have to use combinations. Oh, I erased my thing because I'm going to do a third one. All right, so we got 13 men, 17 women in a club. Same club. So number 3 here, how many ways could they elect a president, vice president, and a secretary? So again, the first question now, probably should ask when you encounter a problem, these problems, because, I mean, sometimes it'll tell you it's a combination, or sometimes it'll tell you what it is, but if it doesn't tell you what it is, you better ask this question. Is this a combination? It's a combination if what? If the order doesn't matter. In other words, CBA is the same as ABC. If the order doesn't matter like that, it's a combination. If the order does matter, it is not a combination. So is this one a combination? Does the order matter, or does the order not matter? We'll just think about it. ABC, is that different or not? CBA, or something rearranged. Is CBA different than ABC? A president, B vice president, C secretary. C president, B vice president. Is that different? That's different, isn't it? Order matters. The order matters. So, is this a combination? No. So if it's not a combination, use the blanks. So we've got president, vice president, secretary. Okay? All right, so that is, how many choices do we have for president? 30. Could either be a man or a woman. How many blanks do we, how many for the second blank, the vice president? Well, you can't repeat, yeah, so 29, and then 28. So we're not going to use the combinations there, we're just going to multiply those together. $24,360.
Now, would that also be like the P?
Or you could use the P, yes.
Yeah.
You could use P on that, but you don't have to. Let me give you one more while we got this up here now. So number 4. Oh, no, that was it. Okay, I'll have to say I'm out of time here.